Welcome to Chapter 10, Data Abstraction and Object-Oriented Programming. Overview of Object-Oriented Programming. Chapter 10, Lecture 1. Abstraction. Before we talk about Object-Oriented Programming, let's look at abstraction. What is abstraction? From the Latin word abs, means away from, and track. Actually, I don't know how to pronounce this word. Meaning to draw is the process of taking away or removing characteristic from something in order to reduce it to a set of essential characteristics. So this one actually means you have a complicated system or something you really don't know, but you try to come up with some essential characteristics. So somehow it is simplified, somehow it actually getting the key points. That's called abstraction. But right here in this chapter, we mainly talk about the abstraction of data abstraction and information hiding or data encapsulation. These are related to object-oriented programming. But the word abstraction basically try to provide the key characteristics. So data abstraction in C language including the lower level is not abstracted, it's primitive data type. That's integer, character, or array. Then you start to have more complicated linked list. Something like that. And then some people will use linked list to implement vector or map. That's a conceptual module. And then that is used, for example, as a dictionary or word set. And then application will do spelling check. That's data abstraction. On the other hand, there's another sense called program abstraction. Program abstraction is I have a C module, .c and .h. I have another one. Each one is a module, and I link them together into a executable file. That's called program abstraction. But OOP, Object-Oriented Programming's job is to combine the program abstraction and data abstraction together. And it has a data abstraction, data encapsulation, and information hiding feature. Object-Oriented Programming. It is the control or process abstraction. Is very the control or process abstraction is a very old idea. So that's the control abstraction or program abstraction. Though few languages provide it in a truly general form. So let's talk about the old languages. But nowadays, every language support object-oriented programming. So it's no longer a valid statement for say in a few languages. Data abstraction is somewhat newer, though its root can be found in Simula 67. An abstract data type is one that is defined in terms of operation that is support. So actually, what this really means is an abstract data type is like something like stack. So stack we know is something like this, and you basically use the push and pop to work on the data structure. So it actually is known by its operation. And rather than the structure or implementation of how the stack is done, it may be an array, it may be a linked list. Both can implement stack. So the abstract data type, actually you hide the detail of how implementation is. You actually only know about the operation. And so that is actually some kind of information hiding. and then you use certain accessor mutator to change the information. Object-oriented programming, why abstraction? Easier to think about, hide what doesn't matter to programmers, protection, prevent access to things that you shouldn't see for programmers, plug compatibility, replacement of pieces, often without recompilation, definitely without rewriting libraries, division of labors in software projects. So for all of these actually are the early idea of why we need object-oriented programming. And in early days, like in early 90s, there is certain words called software IC. That's the early term that used for object-oriented programming. So we have an object here, and then we have different object here, and they connected like a integrated circuit. Somehow there's a bus or something. It's like something like that. The original idea is like something like this. Then we have the test bench to test on that. So you can see that software testing mostly borrow the terminology from hardware testing, workbench, test bench, something like that. And actually, by doing that, you actually have the concept of providing the test pattern into the chip and then getting readout somehow. And you can unplug certain chip, replace by another one, and to test it again. That's a plug compatibility. And also you prevent the access of things that you shouldn't see. So these are different features for object-oriented programming, and early day we call it software IC. So object-oriented programming, you have class, that's a template that has data field and methods. And methods are functions that dealing with the data fields. And objects, you have the attribute and methods. And attributes are actually variable. Methods are actually functions or procedures. So actually there is a similarity between procedural programming environment and object-oriented programming environment. The only difference is this object-oriented programming is a systematic way of doing it. In actually the language itself provides a mechanism and actually has stricter protection for the data. While procedural programming environment, you have a locality issue. You talk about local variable, global variable, but in fact, if someone just try to break the rule or to use certain variable, you have no way to control it. And that's the difference between object-oriented programming and the procedural programming. The principle of object-oriented programming are the key issue, the most top three important issue for object-oriented programming is encapsulation, inheritance, and polymorphism. These three are the most important. And then, because of its reusability, class and object, topic, and some of the OOP even support concurrent programming. So, and also the function is also called as a message passing. In the early day, we called it a message passing. Each function or action is called as message. So we have the message passing, and if it is in a concurrent environment, you have several objects, each one running a thread, and then you try to inform the other object. That can be called as a message passing, and that's related to event-driven programming, supporting the OOP. It also related to concurrent programming. And so OOP itself is a function, a knowledge or a program development way of handling the program using objects. But there are several other terms like concurrent programming. There are event-driven programming. And these are related to object-oriented programming, but it's not one-to-one relationship. And it's not direct mapping of certain feature from one to the other. So by different design framework, you may get different definition for the concurrent programming or event-driven programming. So that depends on the framework. For example, your Python may have the OOP as well, but if you use PyQt for Python, then it's supposed some sort of, they have different way of handling the concurrent programming and handling the events. They use signal and slot. But if you use some other framework, they have different way of doing concurrent programming as well. So that actually also depends on the framework, not only the language itself. And right here, we have several principles to keep in mind. For object-oriented programming, first, you need to encapsulate what varies. For the data, you need to provide the function methods to access it or get it or change it. Call to the interface, not to the implementation. And favor composition over inheritance. Strive for loosely coupled or try loosely coupled design, and don't do highly coupled. Try to enhance the coherence for a certain class. And class should be open for extension, but closed for modification. Actually is encapsulation. And depend on abstraction, do not depend on concrete classes. So try to make things more abstract. And then you have the polymorphism. And then the class should have only one reason to change. That it actually is, this one actually is try to make a class more coherent by itself. Don't put in too many too many mission for a class. Try to simplify its mission. One class, one mission, one single goal. So here are different topics we talk about for object-oriented programming. And Java is a good language for providing a complete knowledge set for object-oriented programming. So that's why Java was used as the first language for quite a long time, but recently it got challenged by some other language like Python. But I believe that at high school level, they provide the AP Computer Science. They are using Java. It should still be around for a long time. And in college level, usually you will see some college start with C double-crossed, some college start with Python. But these three languages, I believe, will be the most popular language for a while and will be something that college students should use. Then they all support object-oriented programming except the C language. But Java itself, I think, is the best pilot language for students to learn OOPs at this moment. Object-oriented programming, we talk about data abstraction in the chapter 3 for naming and the scoping. Recall what we trace the historical development of abstraction and mechanism that have the static set available for basic language, local available for Fortran, for Fortran and Argo 60 and C, module from Modular 2 and Ada 83, module type for Euclid, and object for Smalltalk, C++, FL, Java, Oberon, Modular 3, and Ada 95. So as you can see, the language feature are adding up and then more complicated. So you start to have some variable, and then you have local that belong to some function. So originally you have some data, and everybody can access it. And then you start to have a function, and you put inside some data in the function. And then you provide static that will never change, shared by different functions. And then you start to provide a module to group them together, don't allow people to change from outside, something like that. You have a module. And now this module promoted to become an object. That's the development of the historical development trace for the object-oriented programming. And beyond Java, actually, object-oriented programming had been fixed for a while. The format is just been mature. Static allowed a subroutine to retain value from one invocation to the next, while hiding the name in between. Module allow a collection of subroutines to share some statics, still with hiding. If you want to build an abstract data type, though, you have to make the module a manager. So that actually, we talked about this manager before. Object-oriented programming, module types allow the module to be the object data type. You can declare a bunch of them. This is generally more intuitive. It avoids implicit object parameter to many operations. And one minor drawback, if you have an operation that need to look at the inert of two different types, you'd define both types in the same manager module in Modular 2. So modular, it says that it actually intuitive, and then it actually has a compartment, but actually it have no constructor. And so if you have operation, you basically just provide operation for you to do something. And in C++, you need to make one of the classes a friend of the other, so that actually this friend function actually works a little bit like the static function, in Java. That actually is a share function, but do not operate on the instance itself. It actually provides a friendship function, so you can deal with. It's just like static function as a utility function for the class, but not working on the object itself. Object-oriented programming, objects add inheritance and dynamic method binding, and Simula 67 introduced these, but didn't have data hiding. So there are three key features: encapsulation, inheritance, and polymorphism. Lecture 2, Classes and Objects. Number 1, Basic Definition. Let's look at what are the basic definitions. For a class, you have a class name, attribute, and method. We know about there are two important features. That is, one is the data. The other one is the method that modify or access the data. Okay, and then you have members and non-members. So you have the members will be inherited. These are the data members and the member methods. And the constructor and destructors are used as just like a memory allocation function and also initialization function. And these are not inherited, but is actually being used or being automatically ported to a subclass. So your constructor and destructor actually are just non-inherited inherited feature for a class. So here we have a list node. In this list node, we have a list node. We have a value, a previous data field, a next field, and a head field. That's a list node. And we have a constructor list node and the destructor list node field. And we have a pointer for the list node type, that the body of the element is a list node. And the reference type and this is for C double-crossed language. So here we have a class list error, and this error has a constructor and a data field called description. So that one actually is some sort of exception class, and you can use that to create exception. And then we have a list node, and this node we have that data field as we draw over here. And then there is a data field called val, the value, and then we have a constructor, we have predecessor, successors to find the next one and previous one. We have a singleton test, whether this one is the only list node. And we have insert before, remove, and the destructor for the node. So that is actually a completely package for you to maintain a list node. And then here is a list. So list actually is a container or a group of data using the list node, built by list node. So we actually has the header data field for the list data field for this class, and we have the function of is empty, and then we have the head function, we have append function, and the append actually will use the function insert before that is defined in the list node, and we have destructor for list. So if the header is not a singleton feature, so then you cannot destruct, then you will actually raise the exception, so new list error, and to create a new node, you actually create a new list node, and this new function actually it is a memory allocation function. Use the list node to allocate a new object, and that object's address assigned to element pointer. And in C++, you can actually use this to declare a list, and use this to declare a list node. So private and public members, that's the visibility, and that can be usually defined in the .h file. So these are the private data members, and here we have a public one. And usually you can also write a private on top of it. It actually is like that. So here are the public members. You have a data field and member methods. And separate method definition, you can use the scope specifier, scope resolution operator, that's a double column. So that actually inform the compiler this method is a implementation of a method for the list node class. And then you have the passing a list node pointer, and then you throw exception if it is a singleton. I'm sorry, if it is not singleton, you try to insert a node already on the list, and then you actually modify the insertion of the node. So try to actually modify, put in a new node into a two node. So you actually originally is connected like this. You need to set up the link in between. That's the purpose of having this insert before. And actually is insert before here. And tiny subroutine. Accessor mutator. Accessor mutator are used to update or get the property from certain functions. So here we have the property and indexer method in C# language. C# language here provide property mechanisms specifically designed to facilitate the declaration of method. So we have this one. This one is an implicit call to get methods, and that one is a implicit code for the set method. So basically, you will operate this in C# language, and you actually have the get method, set method. Instead of writing a full function definition, this can be used to in this field in something like this. So right-hand side data field access, you actually use the get method. Left-hand side reference, you use the set method. And that actually is called tiny subroutine. It's not full implementation of functions. Classes and object number 2, derived class. So the first one we talk about more about encapsulation and the data field definition and member methods. And here we talk about the inheritance as derived field. Inheritance of classes we call derived classes. So here you basically have the class name. After that, you have the modifier for the visibility, and this one is a public inheritance of the list type. So actually, Q extends list in public way by writing this in C double-crossed language. And then you have the enqueue, and you have a dequeue as a new function for queue. But the baseline base function, base class used for list is actually the list class. So you actually have a child class. You have actually extend the parent class. The relationship is a relationship. And in Java, you use the extends. Here, you use the column and public for public inheritance and list. And then in terms of this modifier, the visibility, we have separate slides to talk about it. General purpose base classes. High-level classes, we have a general purpose list node. So here we have different function like this. Okay, so it's a less content. So general purpose base class usually sometimes it's people would use object class. But in C double-crossed, actually there is no such language feature for abstract class. It actually has an abstract method, and that actually will make a class abstract with some unimplemented function. So here we have general purpose class, base class. So specific subclass, we have the integer list node. So this one is general purpose. That means it can be used for different data type. But you actually will have the integer list node that actually inherit the general purpose list node. So the general purpose list node is a class over here. And then you have the integer list node type implemented. Maybe you have a double type to implement it to actually extend it. So somehow this general purpose is like a parent class. Overloaded constructors taking different parameters. We use overloaded function for the constructors in int list node, provide two alternative implementation. One takes an argument, the other doesn't. So there is a no argument constructor, and the other has two arguments. I'm sorry. One takes an argument. One has one argument, and the other has two has no argument. So you actually one you can call by this and put the values 13 in there. So you actually can pass the value 13 into this node, and this node has a data field called val, and then you will get the default no argument type with 0. In C++ language, the compiler ensures that constructor for base class are executed before those derived class, and this is also true for Java. In our example, the constructor for general purpose list node will be executed first and followed by the constructor for the integer list node. And these are done in the child classes. So that's overloaded constructor. That means that you have the constructor to allocate new object, memory for the objects, and you have different way of building the object with different parameters. Overriding method is among different subclasses that actually modify the class definition from the base class. To redefine a method of a base class in the derived class, a derived class simply declare a new version, and something like this, you actually have different definition for remove. So you actually just try to implement it in different way. And that's overriding method. So this actually is a better approach that implement detail. If there is definition, then actually you will be able to use the parent class definition. If that is somehow not existing, you can actually throw exception and then catch it to do something. The version of the code might be slightly slower than the previous one, depending on how try block implement, but it does a better job of maintaining abstraction. This version will get updated if G underline list nodes remove function is updated. Accessing base class data field, you actually the member function. Other object-oriented programming language provides other means of accessing the data field. In C++, you use the scope specifier, and Java you use .C# and then Smalltalk use the word super to get the base class function, and Objective-C use this super with brackets. Hiding member of the base class. In C++, public members of a base class are always visible inside the member of a derived class. So public member will always be visible. They are visible to users of the derived class only if the base class name is preceded with the keyword public. So that's public reference, public extension. If we want to keep base list node hidden, we must prevent the user from accessing the head and append methods of the class list. So you can have the prevention of using the private extension for the base class. And to make empty class method visible again, we can call it explicitly using the domain or scope specifier. Visibility in C++, we have public, protected, and private. 3 different levels. Public members is accessible from anywhere outside the class, but within the program. A protected member variable function is very similar to private data field, but it provides an additional benefit of that can be accessed by a child class. So it's called a derived class that can actually access the data field for the protected data field. And private members variable or function cannot be accessed or even be viewed from outside the class. So only the class itself can access the data field. It's called a private one. That is the definition for the data field, but there is different definition for the extension. We will talk about it later. Renaming method in LFL. LFL 1 must explicitly rename the method inherited from base class in order to make them accessible. So you actually need to rename it. Within method of integer list node, remove method of the general purpose list node can be invoked by all remove. So you can use that to rename it. So you keep the method available in the child class using this us statement. Class and object number 3, class relationship. Class basically had two types of relationship, has a relationship and is a relationship. So here we have the nested class have a relationship. As a relationship, we have composition, association, and aggregation. And actually, these three can also be called as association. So a class Maruti actually is extends the class car, but it has a engine. So this engine and Maruti has a relationship, and Maruti and the class car is the relationship is a relationship. So Maruti is a car, and Maruti has engine. So that's the way we read it. So in the class we have non-static or static, and there's a inheritance inner class, local inner class, and anonymous inner class. And so you can put a class inside a class that also have different type, and you can put it outside as a subclass as well. So here we have a class Q. You can actually use this to content. So this is has a relationship instead of using the extension column and public list. That actually is a relationship, but here we have this format has a relationship, and has a relationship and is a relationship has different feature. And usually, if you need to put more data in the child class or the target class, you would like to have use the has a relationship, but has a relationship sometimes it is more complicated. We need more level of using the accessor mutator to access the container contents list in the queue. It probably take more effort to do that, but there are pro and con between the has a relationship and is a relationship. So type of class to class relationship, we have basically association. That's the basic has a relationship. So passenger has airplane, and you have direct association. You have refractive association, that some data object has itself as its own data field. And you have multiplicity. You can have a passenger. A airplane may have many passengers. And we have basically we have another one. A library is made of books. We call this aggregation. And this also is has a but has many relationship. And library need books. That's called composition. And in its a relationship, we has inheritance relationship. or we can use an interface that's realization. So here are different type of the relationship between class and class. So but basically, if you summarize it, it basically is the association that's called has a relationship, or is a relationship for inheritance. And realization is some sort of spatial inheritance. And these different association, multiplicity, aggregation, composition, these are all called has a relationship. They have different definition. For example, the the composition, we usually talk about one-to-one relationship. It's a library lists a book, okay? And if a library made of a book, many books, that's called aggregation. And that's the definition of different class-to-class relationship. And classes and generics. Generic is actually some sort of polymorphism. So best class for general purpose list. You can write a general class as a higher level of parent class and allow subclass. This we call it inclusion polymorphism. So, for example, in Java, you have the object class, and everybody inherit the object class. And maybe there's an object class called number inherited object, and then number class actually inherited by integer double and several different data field. So basically, that's inclusion polymorphism. You have the object class, and then you have the number class, object class, and then you have integer, you have double, both implement, both extend numbers. So this we call the polymorphism. It's inclusion polymorphism, because each of the object concrete data type is a member for object class, and you can use the polymorphism by doing that. And there's another way to operate a polymorphism that's called generic. And generic provide new features and be more flexible. So base type problem with type specific extension. Integer list node can inherit list node class. But what about successor and predecessors? We leave the method unchanged, it won't compile. So you need to do something about it. So as far as the compiler is concerned, successor of integer have no bound data field. So, so in order to make it work, so we provide a generics that actually have different implementation of the function. So here we have the casting. We cast that predecessor to list node type. And static cast is a better way of casting than the parenthesis cast. So here we have a generic list. Instead of using the inheritance structure for inclusion polymorphism, we can have this parametric polymorphism using generic list. And here you have a template. So template, you have type here, and then you put something like this. But something about template in C++ is quite interesting, that you sometimes need to put everything, including the implementation, in the same .h file. That actually is some downside for the template in C++ language. It's not really that flexible. So you actually need to do some implementation inside the template, same file. So you can use the include to make it simpler, but you cannot use different module to do that. So C++ way of doing polymorphism using the generic is somewhat more tedious compared to Java. Generic containers. In object-oriented programming, an abstraction that holds a collection of objects of a given class is called a container. So stack is a container. And then a vector is a container, something like that. Common container include a sorted, unsorted set, stack, queue. These are containers. Dictionary implement as list, as implementation tree, hash table, that are different implementation method for this object class. So here, the list or tree actually is the basic data structure, and then I implement these different ADT, conceptual data type, abstract data type. So all of the major object-oriented programming languages include extensive container library. It's called collections, sometimes for Java and Python. A few of these issues involved in their creation have been hinted in this section. Which class are derived from which others? And when do we say that X is a Y instead of X contains use Y, so has a relationship and is a relationship? Which one should we use? Which operations supported and what is their time complexity? How much memory churn that each operation occurs? Is everything type safe? And how easy is it to iterate over the content of the container? So designing a container has many issues, and generic container is a design for general purpose containers. Chapter 10, Lecture 5, Encapsulation and Inheritance, Part 1, Encapsulation. What is encapsulation? Encapsulation is to wrap up a data and the methods within a class. So outside code can only access the data through the public methods. And by doing this, we actually can find the information. So encapsulation mechanism enable the programmer to group data and subroutines or methods that operate on them together in one place and to hide irrelevant details from the users of an abstraction. Topic of encapsulation including data hiding mechanism or modules in non-object-oriented programming language. Second, the new data hiding issue such as OOP. And then module as manager. So 3 topics basically for encapsulation. Number 1 is module. Number 2 is object-oriented programming. Number 3 is module as manager. Information hiding by module. A module is not an object. A module has the control interface. The client can access the module through that. And then inside data or algorithm or data structure will be secret. And the interface is the header, and the body is hidden. And this is early version of data encapsulation by modules. A module in C language is called the namespace. In C++, it's called namespace for module. And many languages like Python also have the module using namespace. So data hiding in Ada, as a header and body code module. And then data allow header of a package to be divided into public and private parts. And so detail of an exported type can be made opaque by putting them in the private part of the header and then simply then their type in the public part. So basically, you can actually declare type as private, and then you have a full definition over here. But outside can only see your declaration. Module with private section provide mechanism for data hiding. The private part provide the information the compiler need to allocate object inline. A change to the body of a module never force recompilation of any of the use of the module. A change to the private part of the module header may force recompilation. So if you change the private part, it will force the recompilation. It never requires a change to the source code of the user. Affect only visibility on the name static manager type module. Introduce no special code generation issue. If module appear to in the global scope, then data can be allocated statically. If a module within a subroutine, then its data can be allocated in the code stack. So that depends on where the module actually been defined. Usually it depends. Usually maybe the module is bigger than the function. This parameter, when an instance make a call itself, it implicitly passes as reference. And this means differencing in different language. In C++ language, it's a pointer. In Java, it's actually a reference. One more issue arises when a subroutine inside a module. How do you know this variable to use? Which variable to use? This private part may have a variable of the same name with a global or parameter variable. Technique to create a single instance of each module subroutine and pass that instance at runtime the address of storage or appropriate module instance. These addresses take form of extra hidden first parameter. That's hidden first parameter. That sometimes we call this. Sometimes in Python it calls self for every module routine. So something like here, you pass in an length and breadth br into here, and you set the length and breadth. So the first parameter is this object reference. For some language like Euclid, but actually is a hidden parameter. The stack doesn't need that. It's a hidden parameter. Encapsulation and inheritance, part 2, inheritance and visibility. Okay, the previous section, lecture, we talked about the basic encapsulation rule, the data field, the compartment created by module or namespace. Right here, we discuss the visibility rules, private, protected, and public. Public and private part of an object, declaration and definition. Two reasons to put things in the declaration, so programmer can get at them, so the compiler can understand them. So that's good for putting them in declaration. And at the very least, the compiler needs to know is the size of the object. So usually if you know about the compiler know about the type, it's good enough. Even though the programmer isn't allowed to get at many or most of the fields that contribute to that size. That's why private fields have to be in the declaration. C++. C++ distinguished among public class members, access to everybody, protected class members, accessible to the member of this and derived class, private, accessible only to the member of this class. C++ structure is simply a class whose members are public by default. So the structure is public by default. C++ base class can be public, private, or protected. Java visibility, we see this before for Java visibility. Java actually has 4 levels, has a no access level, that's a package level. It actually allows same package assessment, but in C++, we don't have that. We have the public, protected internal, protected and private and internal. So internal, it actually contain classes. Everyone can contain classes. Derived class, no. Derived class cannot access it. So this one is inner class. For inner class, it still can access that. And then for derived class, no access by internal or private. Containing assembly, this internal class keyword allow the assembly. And then anywhere outside the containing assembly, only public can allow it. Okay, these are the visibility in C#. So C# and Java are quite different. C++ inheritance and visibility. C++ mainly has 3 levels. C++ has public, protected, and private. And we explained that already. So class visibility, with the introduction of inheritance, object-oriented programming language must supplement the scope rules of module-based language to cover the additional issues. For example, should private member of a base class be visible to the method of a derived class? So can your private member be seen by the child classes? The answer is no. Should public member of a base class always be public member of a derived class? The answer is yes. How much control should base class exercise over visibility of its member in the data derived class? Basically, no, you actually can define by yourself. Default hiding in C++, the definition of class Q can specify its base, that's this class, to be private. So this one is actually a private extension of list. So the data field in list, when it been a member, when it been extended by Q, all then are being extended in the private format. That means you actually need to pull it with scope specifier, or you need to use some method to access the data fields. Class visibility inhibiting by delete. So here is a delete. That's hiding is exceptional in this case. So this one, you can just put a delete to a method, then actually you won't allow it to be visible. So this is a kind of a good programming feature added to the method. So you have equals 0 that actually will become a abstract method. And then equal delete means in disabled. for functions. So among the derived class, visibility, and base class, you have something that is private, will never be seen by the derived class. Protected will remain protected in public derivation. Well, for private derivation, it will become private. So protected and public, if it is extended in private way, it will all become protected. And if a base case have a private extension, everything will become private. And if it is public, it will remain the same. That's a rule for extension. So encapsulation and the inheritance. Number 3, other topics. Static field and the methods. Static field methods can only access static data. Why? Because static methods are loaded when the class is loaded into the Java virtual machine. Your static method already been there, but object, there's no object, no instance field. So basically, you need to wait until the object being created, then the static method be able to access it. So static method can only access static data because it's already loaded by Java virtual machine. But if instance method can access the static, it already been loaded, and the static instance data that actually is created when the instance being created. So these has differences. So C double class classes may also contain static instant data field, a single field shared by all members of a class. So actually, this one is used for number of circle created, number of bank account created, something like that. As a single data field shared by all members of the class, all different instances. Often used when declaring class constant. To make a field static, the static keyword in front of the field. So this one, C double plus use static, Java use static, C# use static. So this one is used as static code block for Java. And then Scala, there's no static things. And Ruby, you use the 8 sign to create static members, static data fields. So you can refer to the field like other fields. And static variables are also considered to be global. So you refer to them without an instance. So basically, static variable are class variables. And in Python, you have a class variable. You have also have certain you have class variable, and you also have an instance variable, and you also have another level in Python that actually following the hierarchy. In Python, you have static variable, you have class variable, and class only your class and below can access that. And static actually is a global variable for all children's for a certain static class. And class variable is somewhere in under a certain tree, you start to share by some of the branches of the classes. And the static actually started from the basic static top level class. So static data field member methods, you also sometimes call a class variable, but in some languages like Python, you have another level of static data fields and methods. Nested class, inner class. So in Java, you can define a class inside a class. So we have an inner class over here. And in Java, it also allows anonymous class such as this, and this can further be reduced to the lambda expression. Type extension, Smalltalk, Objective-C, LFL, C++, Java, and C# were all designed from the outset as object-oriented programming language, either starting from scratch or from an existing language without a strong encapsulation mechanism. So this without strong encapsulation mechanism. They all support module as a type approach to abstraction, in which single mechanism provide both encapsulation and the inheritance. That's the trend at all time. Several other languages such as Modula 3, Ada, 95, Close, Fortran, they can be categorized as object-oriented extension to languages in which modules already provide encapsulation. So they have module provide encapsulation, and they also have the OOP feature. Rather than alter the existing module mechanism, the language provides inheritance and dynamic method binding through the mechanism for existing records. So you actually add on these two features to the records. So right here is an example for list and queue abstraction in Ada 2005. So here we have a generic list, glist, and then glist package over here, glist, a generic glist extend. I show over here. It has a listing of the functions, and then you have the this one. This node is tag to private, and tagged means extendable, and private means opaque. You cannot see through, not transparent. And then so this one actually is a private data field, and the tagged means it's extendable. So this glist has an error, exception type, list node, and list node pointer, and several functions over here. And you continue over here for the implementation part. Extending without inheritance, C# 3.0 provide extension method which give the appearance of extending and is existing class. So you actually can use this parameter. So you actually provide a certain special mechanism, and then it will operate on current object. So it's kind of extending the class without inheritance. You can actually add, you can actually create a class that can to perform into integer conversion with the method to integer, and you will operate on certain object of this type. And instead of putting into its own another class. So here I define integer, my string to integer. So my string will be converted to integer. So basically, you can also use the class variable name, a class name, and then that to int with my string, and you will convert it to integer. So the difference is here you have a class name, and class name access the static variable, static method, and here you use the instance method, instance to access the static method, and both are fine. Initialization and the finalization, constructor and reference. So before that, we need to know that objects have life cycle. So don't think about objects to be too special. In fact, object is just like a record or a structure in C or C++ language. And then your allocation function, allocate or mallocate, will become the new operator in Java or C++. And at that time, you will call the constructor to create an object for you. And C++ don't have garbage collection, so you basically cannot just by parking your object reference, and then the garbage collector will pick up your garbage that are the object without reference. You cannot do that in C++ language. And in C language, you actually allocate the memory and then you freeze those. And then it's basically following the memory allocation mechanism. And C++, you use the new, that called the constructor, and then use destructor to destruct it. And the Java allow the garbage collection, so there is no destructor. You can call the constructor and then that's it. So here is Java object lifecycle. You have available memory. You have the available memory, and then basically you can allocate, and then you will initialize the object. An object can be destroyed and then be released back to the memory pool. And you may have object that originally have reference pointing to it, but once you lose the pointer, and that object become lost object, nobody is actually referencing it, then the garbage collection mechanism will pick it up later and then mark it as lost memory and put it back to the available pool. Initialization and finalization. Initialization actually is the construction of object. We define the lifetime of an object to be the interval during which it occupies space and can hold data. Most object-oriented programming languages provide some sort of spatial mechanism to initialize. So basically, it's something like new is the mechanism. And when written in form of a subroutine, this mechanism is called a constructor. So constructor will be called by the new operator. And constructor does not allocate space. It's a new operator that allocates the memory space. A few languages provide a similar destructor to finalize the removal of the object body. Initialization and the finalization. Choosing a constructor, reference and value. If the value of R references, then every object must be created explicitly. Appropriate constructor is called. If variable are values, then object creation can happen implicitly as a result of elaboration. Elaboration means declaration right here. So this actually means, what's it called, declaration? This actually means class A and itself, you will implicitly create an object. This is called variable values. So you basically use this and 3, something like that. You can actually create an object. And the execution order when object of a derived class is created in C++, the constructor of any base classes will be executed first before your constructor of the current derived class. Garbage collection. Number 4, that's for finalization. After the memory being lost as garbage, it will be collected and destroyed. Choosing a constructor is Smalltalk, FL, C++, Java, and C# all allow the programmer to specify more than one constructor for a given class. So your constructor can be overloaded. The double exclamation mark in FL is equivalent to new. So basically, on the right-hand side, you have a complex class. You will have creation of new Cartesian or polar, and so you have two constructors, and then you can use the exclamation mark to create a Cartesian coordinate 0 and 1 as a point. I think is a point. And then you can also create in polar system with the pi number, your number and your theta. So your rho and theta is used for your polar system, and polar system actually means that the point is actually the rho over here and the theta is over here. That's actually for your polar system. So here are some Java example by default. Overloaded multiple constructors. So on the left-hand side, the first one, you have a class I and integer I, and then you knew by the default constructor, that's fine, and the I will be initiated to 0. Second case, you have I, but you write a one parameter constructor, then at this time the no argument constructor has been overridden. So this one actually won't work if you call this constructor over here. But if you add it with the no argument constructor, and then it will be fine. And in the next one, you actually try to use this. This is okay as a reference for the object, but this with parentheses as a constructor, that is not good. And the last one, you can use this of 3 that would call a constructor. So if you have no argument, you can actually call this constructor and put in the parameter of 3. Reference and value. Several object-oriented programming languages, including Simula, Smalltalk, Python, Ruby, and Java, use a programming model in which a reference refers to objects. And that is a reference model. Programming model, actually. Other languages like C++, Modula 3, Ada 95, Opera allow a variable to have the value that is the object. So this language have different feature. So Java actually is a programming allow variable to refer to. So this is a reference model. And C# and C++ allow variable to have a value that is an object. And C# and Swift use structure to define type whose variable are values. With a reference model for variable, every object is created implicitly. It is easy to ensure appropriate constructor. So I actually like this every time. C++ compiler ensure that appropriate constructor is called for every elaborated declared object. But the rule it used to identify constructor and their argument can sometimes be confusing. So it has ambiguity in C language, and it's actually harder to have fast prototyping. Declaration and constructor for C++. You can have declaration and constructor like this. This automatically call the constructor. This actually would directly call this a full constructor. And then if you put in some parameter, it will be passed to the parameterized constructor. And then you have this one data object of full type, and then it can be used as the parameter for constructor to build a full object B and C. So here is the copy constructor, and then some assignment cases. So here is the declaration on the constructor for C++. We can create a temporary object. For example, in this case, there is no real assignment of the name, but here you create a string and then run the tabs. And here you have the string A and B. You actually create a temporary object called A plus B in concatenation. And you actually can see that there is some side effect over here. And the new operator, the object created by memory allocation in the heap is like this. So you can actually use a new operator to create a object and then assign the reference to object 1 for Java. But later you can clean it up. So return value optimization. If the return value is not a simple address or simple number, you may have a structure that you need to return. And in that case, your return value need to be optimized. So return value optimization in other program, the compiler may need to invoke a copy constructor. So this is a copy constructor. The allocation of C can be passed to the hidden parameter unless the compiler is able to prove that C's value will not be used during the call. Execution order. Superclass before this, and actually you can, in your declaration, you can actually put some parameter for the superclass constructor, and in that case, you will be initialized with that every time with certain bar variable inside will actually be assigned by the bar arguments. Execution order, member constructor. C++ allow parameterize the member object such like this. All the basically data field can be parameterized, and then C++ allow parameterize the member object as well. Execution order, constructor forwarding. Call a constructor is calling a of one constructor. So we initialize like this, and we have this. And actually we have constructor forwarding. If you assign the 0 value to the list node, and that is the constructor forwarding. Without explicit declaration, both A and B class have their own constructor. Without explicit construction, A will call superclass B's constructor. If you want to explicitly define A's constructor, you may write something like this: super with some parameter. Garbage collection. Garbage collection is to reclaim the space using without the destructor. And destructor is used in Python, the C++. So actually, when you dequeue, you need to dequeue or delete all of the list node. And in Java, actually, you just need the parking portion. So by now,